Hi there, welcome back to my channel. How's it going? Today we're diving into essential topic in combinatorics and algebra, binomial coefficients. These numbers appear in the famous binomial theorem, which provides a structured way to expand expressions of the form x plus y to the power of n. Let's break it down step by step and see why these coefficients are so powerful. The binomial theorem states that for any positive number n, so for any positive integer number n, essentially natural number, we can expand the power x plus n to the power of n as summation combinations n taken r times x to the power of n minus r times y to the power of r, where r takes on values from 0 until the n. A power of x decreases as y increases. And binomial coefficient n taken r is essentially tells us in how many ways we can choose r factors of y out of n total factors. So what it means? To understand this better, let's take a look at the more practical example. Let's see that we have a simple formula, x plus y squared. Now let's try to apply our formula of binomial expansion here. That will essentially be r from 0 until the 2, n taken r, x to the power of 2 minus r, y to the power of r. Let's see, it will be 2 taken 0 times x squared, y to the power of 0, plus 2 taken 1, x 1, y 1, plus 2 taken 2, x 0, y squared, which equals x squared plus 2xy plus y squared. But what does that n taken r really means here? It means in how many ways we can choose r factors of y out of total n factors. So suppose we have x plus y times x plus y, and in total we have two factors. X plus y, this is our first factor, and x plus y, this is our second factor. Now if we try to expand this formula, we'll have x times x times y, plus y times x and y times y times x plus y times y, which equals to y squared. We can see here that we have two distinct selection of y factor. The first distinct selection is xy, and the second one is yx. We have two distinct selections, which essentially equals to our c combinations 2 taken 1. So we have two distinct selections of y with a factor of 1 out of total factors of 2. For the second case, we only have one distinct selection, which is y squared, which is essentially the same as y times y. We do not have any other terms here in our expansion. And for the x, we only have one possible selection here, x squared, y to the power of 0. Also one possible term here, one possible selection. And please note here that we do not actually see at the arrangements. X and y of x are not arrangements. They are distinct terms of our expansion. And the order of y in this product matters. Because these are not arrangements, these are products, so the order of y matters here. And these ones are regarded as a distinct terms of our expansion. That's why we count them using our combinations formula. They're the combinations, because they're the products, not the arrangements. The formula is incredibly useful in algebra, probability, statistics, and even calculus. Now let's see an example. Let's expand x plus y to the power of 5 using this formula. This will be equal to the summation r from the 0 until the 5, c 5 taken r, x 5 minus r times y to the power of r, which will be equal to combinations 5 taken 0, x5 plus combinations 5 taken y, x4 y plus combinations 5 taken 2, x cubed y squared plus combinations 5 taken 3, x squared y cubed plus combinations 5 taken 4, x4 y, xy to the power of 4 plus combinations 5 taken 5 by 5. We just need to calculate the first 3 combinations here, because applying the symmetry of combinations, we can find the results for the rest ones. Like this one will be equal to this one, and 5 taken 1 will be equal to 5 taken 4, 5 taken 0 will be equal to 5 taken 5, applying the symmetry of our combinations. Now let's see, 5 taken 0 will be equal to 5 factorial over 0 factorial times 5 factorial, which will be equal to 1, and which will be equal to 5 taken 5. So that's pretty intuitive. Now let's see what we have for 5 taken 1. 5 taken 1 will be equal 5 factorial over 1 factorial times 4 factorial, which equals to 5, which is also pretty straightforward. We can select one number out of 5 possible numbers in only 5 possible ways, because we only have one number in our selection. For 5 taken 2, which will be equal to 5 taken 3, applying the symmetry of our combinations, we'll have the 5 factorial over 2 factorial times 3 factorial, which will be equal to 4 times 5 over 2 factorial, which is 2 times 5, which equals 10. Now for the rest of our terms, we'll have the same results. So we have x5 plus 5x4y plus 10x cubed y squared plus 10x squared y cubed plus 5xy4 plus y to the power 5. So this shows how binomial coefficients determine the number of ways each term appears in the expansion out of total number of factors. Binomial coefficients count how many ways to select R elements from N elements. The binomial theorems provides a formula to expand x plus y to the power of n type of expressions efficiently. Each term in the expansion consists of binomial coefficients and corresponding powers of x and y. And these coefficients also appear in the Pascal's triangle, combinatorics, probability theory, and so on. Binomial coefficients are a powerful tool in algebra, combinatorics, probability, and statistics, helping us simplify complex expressions and solve counting problems. And in our next videos, we're going to explore different challenges related to probabilities and statistics, and we're going to solve simplest problems that we can encounter in the area of probability and statistics. And thank you for watching this video. I hope you found this video helpful. If you have any questions or suggestions, please feel free to leave them in the comment section below. For more technical solutions, please join our Discord community. You will find the link in the description. You can also connect with me on LinkedIn to stay updated in future content and mathematical discussions. I wish you all the best in your learning journey, and as always, see you in the next episode. Take care.